the sequence xn equal to under root of n plus 1 minus under root of n converges to 0 for every n belongs to n. So here we want to show that the sequence xn is equal to, so given xn is equal to square root of n plus 1 minus square root of n, the limit L is equal to 0, and we can say that the sequence xn is converges to L if for every epsilon greater than 0 there exists a positive integer m such that xn minus L is less than epsilon for every n greater than or equal to m. So if we consider here xn minus L, if we consider xn minus L, then it is equal to xn is square root of n plus 1 minus square root of n plus limit is what? 0. So it is equal to mod of square root n plus 1 minus square root of n. Now this term can be written as, we can write this as, if we simplify this, if we square root of n plus 1 minus square root of n into, we are going to multiply and divide by square root of n plus 1 plus square root of n divided by square root of n plus 1 plus square root of n. Now we know that a minus b and into a plus b is equal to a square plus b square, and therefore the square root of n plus 1, this is the a and this is the b, so it is equal to n plus 1 square root of n plus 1 square is n plus 1 and a square minus b square, not plus, here a square minus b square, and square root of n square is n divided by square root of n plus 1 plus square root of n. So here plus n minus n get cancelled and it is equal to 1 divided by square root of n plus 1 plus square root of n, which is equal to 1 divided by square root of n plus 1 plus square root of n, and therefore xn minus L is equal to xn, from this we can write xn minus L is equal to 1 divided by square root of n plus 1 plus square root of n. Say this is equation number 1. Now as we know that n plus 1 is greater than n, this implies, from this we can write square root of n plus 1 greater than square root of n. From this we can write 1 divided by square root of n plus 1 is less than 1 divided by square root of n, and therefore equation 1 can be written as xn minus L is equal to 1 divided by square root of n plus 1 plus square root of n, equation 1, okay, which is less than 1 divided by, as this square root of n plus 1 is less than square root of n, and therefore it is less than square root of n plus square root of n, and this implies xn minus L is less than 1 divided by 2 square root of n, and which is we write this as less than epsilon. So now if If 1 divided by 2 square 1 divided by 2 times square root n is less than epsilon, implies xn minus L is also less than epsilon. And therefore now since 1 divided by 2 square root of n is less than epsilon, implies 1 divided by square root of n is less than 2 epsilon, and hence from this we can write square root of n is greater than 1 divided by 2 epsilon, and this implies n is greater than 1 divided by 4 epsilon square. So here if we select a positive integer, select here m, a positive integer such that which is greater than 1 divided by 4 epsilon square, and m is positive integer. For this m, the distance, the square root of n plus 1 minus square root of n minus 0 is less than epsilon if n greater than or equal to m, where m is positive integer greater than 1 divided by 4 epsilon square. Okay, and hence this is true for any epsilon greater than 0, and therefore limit n tends to infinity, square root of n plus 1 minus square root of n equal to 0. Thank you.